Hello, children. My name is Professor Pewterschmidt, and today we're going to be talking about kernels. Yes, computer kernels. Oh, it's a fascinating subject. In fact, computer kernels are some of the most important parts of the operating system because they are the basis of the operating system. You can't have the rest of the operating system without the kernel. The kernel takes control of all the security and the privacy and all of the hardware. Computer kernels are very, very important. And at the end of this presentation, you'll have a greater respect for the app.
To a younger audience, a new mascot will be used.
Hello kids, my name is Charles, and I'm here today to talk to you about computer kernels. Computer kernels are the most basic and important part of an operating system. They control the flow of data between the software and the hardware of a computer. So without the basic kernel of an operating system, computers wouldn't really do anything, software wouldn't run, and hardware wouldn't be used. Kernels have to make sure that everything connected to the computer can run, and they do this using device drivers, which we'll go over a little bit later. They also have to keep track of which process is allowed to run and which pieces of hardware it is allowed to use. Today we are going to talk about some of the different kernels that work in operating systems, such as Windows and Apple, Linux, and Unix, and even some new experimental operating systems. First, we're going to talk about two of the large divisions and different types of kernels, a monolithic kernel and a microkernel. See, a monolithic kernel is one big giant kernel that takes care of everything. It has functions that take care of security and networking and memory access, while a microkernel is a whole bunch of smaller kernels, which each kernel is separated into different sections that it takes care of, like the networking and input and output devices and so forth and so on. Maybe you're wondering why a squirrel knows so much about operating systems. Well, that's because up until recently, I had been working at Microsoft.
Hey squirrel, we're downsizing and we're outsourcing to another country. Pack up your things and leave.
Now we're going to talk about microkernels. And a good example of microkernels would be Apple's OS X operating system's kernel. This has 5 microkernels with it: Mach, BSD, the networking, the input-output kit, and the file system management. Mach is the foundation of the operating system and provides the low-level services such as memory allocation, process management, and scheduling. The BSD microkernel is powerful enough to run the entire operating system on its own, but instead is used in conjunction with the Mach microkernel, allowing both microkernels to be able to be more specialized and run faster. Another one of the microkernels is the networking, which is implemented at the kernel level to allow for dynamically extending the network abilities of the operating system. The input-output kit of the microkernel is the part that takes care of the device drivers for the operating system, which will be talked about in a little while. The final microsystem in the Apple's OS X is the file system management microkernel. This is able to use such systems as the Apple standard, the hierarchical filing system standard, as well as the extended hierarchical filing system, the Unix file system, the network file system, and the ISO 9660, which is the International Organization for Standardization system, which is mostly used for organizing CD-ROMs. One of the most important tasks of an operating system's kernel is that of security. Here we will show you an example of how security works with our two guests, Sharks and Seal. In this case, each of them will represent a process. Process 1 will be the Seal. And process 2 will be the Shark. In this example, both processes need to use a resource. We will call the resource the Rocky Bluff Beach in Southern California, which I hear is very nice nowadays. Now, in an ideal situation, the Seal would use the waters for hunting and playing and relaxing, and then once the Seal was done, the Shark would be allowed to use the waters. When the schedule or security is not working, some problems can occur, such as the Shark and the Seal may be in the same resource at the same time, and the processes could have nasty effects on each other. See, here's the Seal using the resource, enjoying the water, having fun and playing, and uh-oh, something happened with the security and another process is coming in the background. Do-do, 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 do-do-do-do-do-do-do-do. Ah! Blood effect. Scheduling is another very important part of the kernel. The scheduler is what allows an operating system to multitask, by allowing each process to run for only a small amount of time, so that no one process takes up all of the processor's time. Kind of like my Uncle Jimmy taking up the bathroom the whole night after Thanksgiving.
Oh boy, Charlie, tell my wife to break out the emergency pants.
Kernels also manage the device drivers, which allow you to plug in any device you want and use it. The device drivers contain all the information that the kernel needs to communicate with whatever device is connected to the kernel. Whether it's a hard drive or a mouse or a zip drive or even a USB fan. Why do you need a USB fan? Why? Sheesh, what's next? A USB soda can cooler?
And I said, look, Mom, I'm riding the fan, and whee! Looking ahead to the future, there are some exciting new kernels out there. One of them is a new category of kernel called the exokernel. This kernel removes most of the privacy and security from the kernel stage and instead allows for each process to manage its own privacy levels. This also requires a large increase in inter-process communication. From this process communication, many new and exciting abilities can come from this new level of freedom and communication that processes would receive. It even allows for communication between processes of different operating systems. Just think of the possibilities. Write something in Unix and write it in your Windows PowerPoint. Here's what we would expect process communication to be like in the future.
Hello, I need to eat you for nourishment and to continue my life processes.
But if I allow you to partake of me, then my life processes will end.
But if I do not partake of you, then my life processes will end.
My, this is quite a conundrum. I know. Why don't you partake of the excess bacon resource? This will allow you and I to continue both of our life processes.
I am unsure of this bacon that you speak of. Allow me to sample it. Stop recording. Say, this bacon is quite tasty, and it seems to have helped stop my hunger functions for the time being. I am pleased with this, and will not partake in eating you.
I am pleased by this.
Oink! Each Linux kernel has a unique number. A kernel's release number can be broken up into 3 different parts: the major release number, the minor release number, and the patch level. Major releases can have fundamental changes in the kernel architecture. So far, there have been only 2 major releases. Minor releases are less radical in architecture change, though even minor releases of a Linux kernel version can bring significant improvements in performance and features. For version 2 of the Linux kernel, there have been 4 minor releases. The patch level of the kernel denotes an official release that groups a set of patches made to. Generally, work on the Linux kernel proceeds along 2 parallel paths: a development kernel or stable kernel. A development kernel emphasizes cutting-edge features and performance. These kernels resemble beta software. Those kernels are somewhat untested and may contain bugs. They are assigned odd minor release numbers. Eventually, development kernels form the basis for the next stable kernel release. A stable kernel emphasizes ongoing refinement and eradication of defects. These stable kernels are then assigned an even minor release number.
These numbers are very important as they can help tell you how new or stable the kernel is. Because Linux is an open source, anyone can edit it and put it out on the internet. This is different from Windows, where only a few people know about how it works. Except for Windows 2000 now, it was leaked out on the internet. Gee, I wonder who could have done that. Maybe Microsoft shouldn't fire anyone small enough to fit into the air ducts.
And now she wants the house too. At least I still have all my hair. Oh, hello children. Well, I really hope you learned something today about kernels and about how they're used and about ways you can use them in the future. And I hope that you grow to get a respect of kernels because they're very important in operating systems. Thank you. Goodbye now.